Hi everyone, and welcome back to the lab. In this video, I'll be making a compound called Pyridinium Chlorochromate, or PCC for short. It is the quintessential textbook method for oxidizing alcohols to aldehydes without over-oxidizing them to carboxylic acids, like something like potassium permanganate might do. It's simply the pyridinium salt of chlorochromic acid, as you can kind of tell by this diagram here. So first we're just going to have to form some chlorochromic acid. Fairly simple. We'll just dissolve some chromium trioxide in water to form chromic acid, add hydrochloric acid to it, which will form chlorochromic acid in equilibrium with a bunch of other things. This is a very simplified diagram here. And then we'll neutralize that solution with pyridine, so this is all in a 1-to-1 ratio, and that will form the pyridine salt, or the pyridinium salt of chlorochromic acid, which is pyridinium chlorochromate. And this happens to be convenient because it precipitates, especially when the solution's cold, and then we can filter that off and dry it for future use for oxidizing alcohols to aldehydes. I'm thinking maybe benzaldehyde? I don't know. Anyway, that'll be a future video, but for now, we'll make some pyridinium chlorochromate. Let's get to the lab and do it. To begin, we'll prepare the solution of chlorochromic acid by mixing hydrochloric acid and some chromium trioxide. Now I have hydrochloric acid, but it's a little too concentrated for this application, so I've got enough water here to dilute it down to 6 molar, and that'll be a total of 184 milliliters of 6 molar HCl when those two are mixed together. I also have here 50 grams of commercial chromium trioxide flakes. It actually looks almost like fish food, but you definitely would not want to feed that to your fish. Probably dissolve your fish or you catch it on fire. So first the HCl into this beaker with some stirring. Always remember, of course, add the acid to the water. HCl doesn't really make too much of a difference, but it's a good practice anyway. Speed up the stirring a little bit. And now I'm going to slowly add the chromium trioxide flakes. There we go. And I'll let that stir for a little while to make sure everything's completely dissolved. Alright, everything has now dissolved, and you can see that we now have this sort of homogeneous cherry red, orangish liquid. And I'm just going to cover it really quick with a watch glass to prevent contamination and stick it in the freezer. I'm going to cool this down to about 0 Celsius. Okay, the solution of chlorochromic acid has cooled sufficiently. It's now down to a little less than 0 Celsius. Kind of overshot, but that's not a big deal. And then to it, over the course of about 10 minutes, I'm going to add 40 milliliters of the pyridine I made in a previous video, carefully and with rapid stirring. You can see the pyridinium chlorochromate precipitating. Alright, the last of the pyridine has been added, and I'm just now stopping the stirring, and you can see that we now have a bright orange, voluminous, sort of heavy precipitate in the beaker, which is the pyridinium chlorochromate. The solution got quite warm because of the reaction, the salt formation that is, so what's going to happen is I'll stick this in the fridge, or the freezer for that matter, to precipitate as much of the pyridinium chlorochromate as possible, and then we can go ahead and filter off the product and then dry it. Alright, the solution has been in the freezer for a little while, and I just checked the temperature. It is in fact 0 C, and you can see that it's almost solidified. It's full of a nice crop of pyridinium chlorochromate, this sort of neon orange colored precipitate. I'm just going to try and break up as much of the chunks as I can. They sort of formed on the sides and stuff. I think it was starting to freeze a little, so as soon as the chunks are broken up, then I'm going to go ahead and vacuum filter. As you can see, I've set up for vacuum filtration, and we'll just quickly pull the supernatant liquid off of this precipitate. Alright, that's about as good as I'm going to get the beaker, so I'll push this down to settle it out, and we'll start the vacuum. and suck the liquid out of this. Some is already dripping through. Filtering rather quickly. And you can see that we're left with orange powdery solid up here. Alright, I'm going to leave this on the vacuum for about 10 minutes just to get as much water as I can out of it. Normally you'd wash a filtrate with like cold deionized water or something like that by pouring some on and running it through. But you'll notice that in this preparation, most of the contaminants that are in the solution anyway, are volatile, right? You have hydrochloric acids, water, and pyridine, and some chromium trioxide, although with a little bit of excess pyridine you can eliminate that. So, long story short, we don't need to wash this because since the contaminants are volatile during the drying phase, as long as we have a good fume hood, we can just simply drive those off and it won't pose a problem. So anyway, I'm going to leave this on the vacuum for a little while and I'll come back when this is mostly dry. Okay, so I've been pulling a vacuum on this powder for about 10 minutes and I just turned it off. And you can see I've pulled most of the liquid from it and it is reasonably dry. It is now a extremely bright, vivid orange, very fine powder. And then the last step, of course, is just to get this on a plate and dry the volatiles off and allow it to dry. So I'm going to go ahead and do that. Nice and clean. Alright, I've just finished spreading this out, so now the last thing is just to get this on a water bath and dry it nice and slowly until we have our pure dry product. Alright, so here is the dry Pyridinium Chlorochromate product, and I'm just going to put this in a bottle. I initially put this on a water bath, but unfortunately it looked like the water bath had begun to melt this. And I don't think it was actually melting, I think it was dissolving in the remaining solution that was wetting it. But I didn't want to take any chances with decomposition or anything, so I decided to take it off the water bath and leave it overnight instead. So after overnight, this is the final product. I'm just going to load this into a suitable container. And there we have it, a jar and nearly 3/4 of Pyridinium Chlorochromate. I'm going to go ahead and weigh these and figure out how much we have here. Alright, this represents 99.2 grams of Pyridinium Chlorochromate, and I'll be using this in an upcoming video to oxidize an alcohol to an aldehyde. Before I end this video, I'd like to say a special thank you to those who donated in the month of December to the Patreon account to make the January videos possible. This Pyridinium Chlorochromate I'm holding in my hand was made possible by you guys, and I'm definitely going to do some really cool stuff with it. But not only this, in fact, there are some things in the mail that I'm going to keep secret for now, but I guarantee you there are some pretty cool things coming up in this channel, and that is all because of my donators. So thank you very much. I'll put your names on the screen now. That said, if you haven't made a donation and you'd like to make a donation, I'll put a link to my Patreon account in the description of this video. 25 cents, 50 cents, $1, whatever you got. It'll help me out because believe me, with a lot of you guys, it adds up really quickly and I can make really cool videos like this one and the ones I'm going to make with this and the secret videos with the stuff in the mail. So really appreciate that. It's going to be great. I like making these videos a lot, and if you like these videos, please press the like button. Press subscribe if you want to see more. Leave me a comment if you want to, and I'll try and get back to you. I try and answer as many comments as possible. And as always, thanks very much for watching.